All right, let's pull back the curtain on the digital magic that happens, every single time you go online. We're going to trace the journey of your data from just one click all the way to its destination and back, and it all happens in milliseconds. So, you click a link. It feels instant, right? But in that tiny fraction of a second, this incredible journey is taking place. We're going to follow just a single piece of your data from your screen out into the huge world of the internet and all the way back home. But before our little data packet can even start its journey, we really have to understand the world it lives in. And it all starts with the very foundation of the internet, the computer network. And at its core, it's really that simple. A network is just a group of computers that can talk to each other. Now, this can be something as small as the Wi-Fi network in your house that connects your phone and your laptop, or as absolutely massive as the entire global internet itself. So why do we even have networks? I mean, what's the point? Well, this slide gets right to it. Networks aren't just for connecting stuff. They let us share resources, like a printer, communicate instantly across the entire planet, save money, and make sure our data actually gets where it's going reliably. Okay, so how does your request get ready for its big trip? When you click a link, your computer doesn't just send one giant file out there. That would be, well, incredibly inefficient. Instead, your request, doesn't matter if it's for a website, a video, or an email, it gets chopped up into these tiny, manageable pieces called packets. You can think of it like trying to send a really long book, but one page at a time on thousands of tiny individual postcards. And because these postcards are out in the open, this is where data encryption becomes absolutely critical to keep what's inside private. Exactly. A postcard is pretty useless without an address, right? Our digital packets are no different. They need a destination, and finding that digital address is the first, most critical step. And this is where something called DNS comes into play. The Domain Name System, or DNS, is basically the internet's giant phone book. Your computer sends the human-friendly name you typed in, like theexplainer.com, to a DNS server. That server looks it up and sends back the computer-friendly IP address that's needed to actually find the website. And this is a really crucial point. Every device has two different addresses. The MAC address is permanent, it's baked into the hardware, it's who the device is. The IP address, though, that's temporary. It's where the device is right now on the network. It's kind of like having your name versus having a mailing address you use while you're on vacation. Okay, so our packet has its IP address stamped on it. It's ready to go. The very first part of its journey is just leaving your device and navigating your local network. And the very first stop for your packet, that's going to be your home or office router. This is the gateway from your own private local network out into the vast public internet. Think of it as the local post office for all your data. And this is its whole job. The router reads the destination IP address on your packet and acts like a traffic cop. It checks its own maps to figure out the best, most efficient path for that packet to take. And for most of us, this router also acts as a security guard, running a basic firewall to block any incoming packets that look suspicious. It's your network's first line of defense. And with that, our packet leaves the quiet residential streets of your LAN, your local area network, and merges onto the chaotic, high-speed global superhighway of the WAN, the Wide Area Network. In other words, the internet. And it travels using this truly brilliant system called packet switching. What this means is that all those little postcards we sent don't have to follow each other in a single file line. Nope, they can take completely different routes all across the globe to avoid traffic jams. This resilience is really the internet's secret weapon. If one path gets blocked, packets just find another way, which makes the whole system incredibly robust. So your packet just zips from router to router across continents, probably through some of those massive undersea fiber optic cables. Maybe it even gets bounced off a satellite, making dozens of little hops on its way to the destination server that's hosting the website you want to see. Now, when the packets start arriving at the server, how does the server know it's getting everything correctly? How do the two computers establish a connection they can trust? Well, they do it with a process called the TCP handshake. And this explains it perfectly. It's a quick, three-step conversation. Your computer sends a SYN packet, which is like saying, "Hello, you there?" The server responds with a SYN ACK, which means, "Yep, I hear ya." And then your computer sends a final ACK to say, "Great, let's connect." It's a digital handshake to make sure the line is clear and stable. With that handshake complete and a solid connection established, the server can now get to work. It gathers up all the website's data, breaks it into brand new packets, addresses them to your IP address, and sends them on the exact same journey, just in reverse. So let's just take a step back and really look at this incredible, almost instantaneous process that we've just walked through. From your click to the DNS lookup to your packets crossing the entire globe, the handshake, and the first bits of data arriving back, all of this happens in less time than it takes you to blink. This total round-trip time, that's what the tech folks call latency. And minimizing it, even by a few milliseconds, is a multi-billion-dollar obsession for gaming companies, stock traders, and pretty much anyone who needs speed. You know, in the end, it all comes back to this very simple definition. But inside that simplicity is this incredibly complex, elegant, and seamless dance of data packets that powers our entire modern connected world. This fundamental architecture, this whole journey of a packet, it's what makes everything possible. From streaming a movie to video calling a loved one on the other side of the planet. It's the foundation of our digital lives. So the real question is, now that you know how it works, what comes next?